Hey everybody, in this video we're going to talk about more experiment designs. We've already been kind of introduced to this situation. We're pretending our school, like we're trying to see what ACT prep course is better. Are you going to be better off taking the online version where you're able to work at your own pace and you just watch videos, pause, play, ask yourself questions, self-reflect and stuff? Or are you better off taking the prep course in person, either like, after school and on Saturdays where you can ask a teacher questions about questions on the ACT. So in this experiment, we've got 50 student volunteers that have already taken the ACT, and our response variable is the change in ACT score. So of course, to perform an experiment, right, the first principle for that design would be we need to be able to compare, and that's why we have two different treatments here. We've got the online and in-person program. So we've already designed this using a completely randomized design. That was where we just took all 50 students. Maybe I can just actually sketch this out real quick. It won't take long. We've got the completely randomized design. Again, where we take all 50 volunteers, all 50 students. We put them through some random process. And after they undergo this random process, since we have two treatments, we might as well have two groups. We'll have group 1 and group 2. Now, within these groups, that will decide which treatment they take. So again, these 50 volunteers, they'll undergo some random process. I'm assuming we'd want 25 students to be in group 1 and 25 students to be in group 2. Group number 1 can do the online prep course. Group number 2 can do the in-person prep course. We'll do this for so long, they'll eventually take the ACT. We'll gather those results, pull them together, and then we can compare. We can compare the effectiveness of the in-person prep course, or the online prep course for the ACT. So there's some issues with the completely randomized design. Sure, this will give us some decent results, but the issue is really in that response variable. We're comparing the change in their ACT score. Compare the change, should absolutely add that. Compare the change of the student's ACT score. So the issue is that within these two groups, it could have happened, even though we went through some random process, like the students in group number 1 had much higher ACT scores to begin with. So that means they're not going to improve as much as the in-person group who had lower ACT scores. The point I'm trying to make is if a bunch of students in group number 1 had like 30s and 31s on their ACT, it's going to be really hard for them to increase their score. Whereas if we randomly assign group number 2, but they had a lot of students that scored like 19s and 20s, their average change is going to be a lot greater. Just because it's easier to improve a score of 20 than it is going to be to improve a score of 30, because the max score is 36. So the way around this, the way to kind of guarantee that you reduce the variation in your results is to do another type of experiment. So this is called a block design. This is called a randomized block. So blocking places students into categories, kind of like stratification for sampling, before they undergo that random process. So here's what a randomized block design would look like for this situation. So again, we start off with our 50 volunteers. Now, before they undergo this random process, we're going to block them. We would say block number 1, block number 1. Block number 1 could be, I don't know how we're defining this, but we'll place all the students that had a high ACT score into block number 1. And then in block number 2, we'll just randomly assign some of these volunteers into block number 2, and those are students with low ACT scores. You can make the threshold whatever you want. You probably want the group still to be just about the same. So in block number 1, we'll probably have around 25 students. And in block number 2, also we'll have around 25 students. So blocking occurs before randomization. You place the subjects, volunteers, experimental units into blocks first, and then you randomize. So now that we're in this block, kind of what our groups were up here, but there's less variation within this block than in this group. We've guaranteed that people in block number 1 have higher ACT scores. So now that we have this block created, we will go through this random process. We'll randomize this block and place them into our treatment groups. So within this block, these students are going to get randomly assigned to either taking the online prep course or the in-person prep course. Same thing for this block. These individuals will get randomized and placed either into the online prep course, treatment number 1, or the in-person prep course, treatment 2. Now, within these treatments, we can get results. Get results there, get results here. And finally, we can compare the effectiveness of our treatments. We can compare the change in ACT score, compare the change in ACT score overall. So again, what we've done is guaranteed that we have some low score ACT students taking the online prep course, and we've guaranteed that we have some high scoring ACT students that are taking the online prep course, and the same for the in-person. Once again, what is randomized block designs? Like, what are they good for? It's reducing variation. These results are not going to be as varied. These ones should have about the same amount of change, whereas before, if in group number 1, just the students that were randomly assigned to group number 1, if they just typically had lower scores than group 2, and they took a prep course online, their scores are probably going to increase by a lot. By blocking, we reduce that possibility. We reduce that variation possibility, or the possibility of the variation being like that high. Okay, so blocking. What is blocking? You place people into categories before you randomize to reduce variation. Now, within block designs, there's also a special case scenario. Within blocks, there's a special way of blocking, and that is called matched pairs. So I'm not going to draw the entire diagram for this one, but we'll get the idea. So matched pairs, it's a special type of block design. It's a block design where individuals are grouped as closely as possible. Individuals are grouped as closely as possible. All right, so if I just start the picture off, I think it'll make pretty decent sense. So once again, we're starting off with these 50 volunteers. And within these volunteers, we're going to place them into blocks. So rather than just grouping all 25 students into some high scoring ACT group, a matched pairs design is even more specific than that. Since we have 50 volunteers, we're going to have 25 blocks altogether. Pairs, we're pairing these together. We're blocking in groups of 2. So our first block will have the two highest scoring ACT score students. 2 kids that scored the highest on the ACT will be in our first block. And then we'll randomize. And one of the 2 highest scoring ACT students is going to get the online prep course, and then the other one's going to get the in-person. So again, then we'll randomize. One of these 2 students is going to get the online prep course. One of them is going to get the in-person prep course. And then, so we've got like essentially like in ranks, we've got the top student in this group and the second top scoring student in this group. So The next block, the next matched pair would be the third and fourth highest scoring students. And then we'll randomize and then send them to a treatment, be it online or in person. So this will give you even better information, right, in terms of this experiment, because these two students probably had like 34s on their ACT. And so one of these 34 scores is going to take the online version, the other student is going to take the in-person, and that should give us a better comparison. If the student in the online prep course improved, but the student that had a 34 in the in-person prep class did not improve, we can probably say, all right, looks like the online version is actually better. And then we can look at our second block, our second matched pairs, and see there. Do we have the same thing? Was the student in the online version performing better than the student that did the in-person version? And then that'll go down all the way to the 49th and 50th students. So they had probably some pretty low scores, like, I don't know what's low in the ACT, like somebody had a 16 and a 15, and then they get randomly assigned to a treatment. So they're both going to be projected to increase by quite a bit, but which treatment caused the student to increase more? If we see across the board that the online student was like increasing at a higher rate than the in-person student, then we can say that, well, it looks like the online treatment is working. We should have our students do that class. That's it for these different experiment designs. We've got the randomized block, blocking based off of some common characteristic, and then matched pairs is a type of block design that is even more specific. It pairs the two students, in this case, that are as close as possible. There's one more type of matched pairs that I'll probably just talk about in class. So matched pairs, you're either paired together with your most common counterpart, or another type of matched pair design is when you serve as your own control. You serve as your own control. So you're not paired with somebody, but you get both treatments. You're not paired with somebody and one of the two of you get one or the other treatment. In matched pairs, you get both treatments. So I'm not going to be paired with anybody. I more have like a pair of treatments that I'm getting. That's really what it means. So you get both treatments and see how you respond. Okay, hey, thanks for watching. I'll go over this stuff in class as well, of course, but yeah, hey, see you there. Bye-bye.